Welcome. This lesson is from page 300 and 301 in your student book. Your objective is you'll be able to determine whether a relation is a function, and you'll create function tables. And what is a function? How can you tell if a relation is a function? And also summarize independent and dependent variables in your summary. So a function is a special relation where each member of the domain, remember that's the x, the input, is paired with exactly one member in the range. Remember that's the y or the output. Okay, so in the first example, each person here has chosen one color they like the best. So because each one has only chosen one that they like best, it is a function. In the next one, Ted likes red and Sue likes red, but they each have only chosen one, and so it is still a function. In the next example, Amy said she liked green and white, so because she chose two of them, it is not a function. Oops. There we go. It's not a function. And so to be a function, the domain can only pair with one member in the range. Remember, the domain is the x, the range is the y. All right, here's an example. Is this a function? Student 1 said they only had 2 pets. Student 2 said they have 5 pets. And student 3 said they have 7 pets. Because they each gave one specific answer, it is a function. In this example, Beth likes just toast, and Adam says he likes cereal and fruit. So because he chose 2 for breakfast, or 2 that he likes for breakfast, it is not a function. All right, example of functions that are written as an equation. It may look different, but it really isn't complicated. You'll see it written as the function, and then in parentheses, x. And then it'll tell you what that equals, 15 times x. So how it's read is the function of x, and then it'll give you the equation. And you'll usually plug in whatever number they give you here for x. So for the first example, one DVD costs $15. So you would say 1 is your x. 1 times 15 is 15. 2 is your x. So 2 times 15 is 30. 3 is your x. So 3 times 15 is 45. And as you can see, the pattern would continue. 4 DVDs would be 60, and 5 DVDs would be 75. But don't be thrown when they show you the function of x written this way. And then the variable is any real number in the domain. Okay, so here's an example. Find the function of x if x is 5. You'd see it written here, and you would just substitute 5 for x. 5 times 5 is 25, plus 4, 29. So here, solve if the function of x, if x is 2, so 9 minus 2 is 7. Here, solve for the function of x, if x is negative 4, you plug in negative 4 right here. Negative 2 times negative 4 is 8, and then 8 plus 1 is 9. Okay, so today or in your assignment, I should say, on Wednesday on your assignment, you will be asked to make a function table. And the function table, sometimes they'll give you the x, and sometimes they'll just say you pick 3 or 4 numbers to be x. And I always require that you have at least one negative. The 0 is a pretty easy one for solutions, and then one positive. So here I've chosen negative 1, 0, and 1. And so you would just use x put the rule in the middle of your function table. So you'd have -1 minus 3 more is -4. That's your output. That's your range. Keeping the rule in the middle, 0 minus 3 is -3. 1 minus 3 is -2. So this would be your x, this would be your x, this would be your y, and this is the rule in the middle of the function table. Okay, the domain, super important that you write these two variables, very important that you write these two definitions, The domain is the independent variable because it can be any number. The range the range y is the dependent variable because it depends on the domain. So one more time, domain is x, it's the independent because you can pick it to be any number. The range y, the y part, is the dependent because it depends on whatever the x was. All right, the function table again, we'll come back to that independent and dependent. The function table again, solve using this rule, and here are your x's. And I'll just have you go ahead and fill that in your notes. And as you can see, PEMDAS, you'd multiply first, subtract 1. Multiply first, subtract 1. Multiply first, subtract 1. Multiply first and subtract 1. All right. Now, getting back to the independent and dependent, you would say there are about 550 crackers in a box. To find the total number of crackers in any given number of boxes, the function would be how many boxes, how many crackers if there's 550 in each box. So are the crackers or are the boxes the independent part? The independent part are the boxes because we can pick whatever we want that to be. We can say if there's 3 boxes, 5 boxes, or 10 boxes. The dependent part is the number of crackers because the number of crackers depends on how many boxes we pick. So independent are the boxes, dependent are the number of crackers because it depends how many boxes we pick. And then you would say domain and range are all whole numbers because you wouldn't count half a box. You would only count the whole numbers. All right, you sell lemonade for $2.25 a glass. That's a lot of money for lemonade. The total sale can be represented by the sale depends on how many glasses at $2.25 a glass. Tell what's the independent part and what's the dependent part. And we would say the independent part is the number of glasses we pick because we can pick that to be any number, 2 glasses, 5 glasses, or 10 glasses, or any other number. The dependent is our total cost of sales because our total cost of sales depends on how many glasses we sold. Domain and range, again, you would just say any whole number because we would only count the whole glasses sold. Oh, and that's the end of our video. Great job taking notes. I know that was quite a few new things. Try to have your summary done before class, and then we'll talk about any questions that you're still not understanding. Thanks. Have a great night.